Assalamualaikum warahmatullahi wabarakatuh. My name is Nazamin Al-Karimi, metric number 213207, and I'll explain about the definition of capacitance. Any combination of two separate conductors can act as an electrical circuit element and is called a capacitor. The conductors are called plates, and if the conductor is charged, uh, which is the capacitor, the plates carry charge of equal magnitude and opposite sign. Uh, the the function of the capacitors is to store the charge, and the second one is the capacitance. Capacitance can be defined as the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between the conductors, and its equation can be defined as C, which is the capacitance, equal to Q, which is charge over delta V, the potential difference. Then we move to the combinations of the capacitor, either parallel or series. The first one, for the parallel, the left plate of the capacitors are connected to the positive terminal of the battery for a conducting wire and are therefore both of both at the same electric potential as the positive terminal. Likewise, the right plates are connected to the negative terminal and are both of the same potential as the negative terminal. Therefore, the individual potential difference across the capacitors connected in parallel are the same and are equal to the potential difference applied across the combination, that is delta V equal to delta V1 equal to delta V2. And the total charge stored by the combination of two capacitors is the sum of the charge on the capacitors, which is Q total equal to Q1 plus Q2, and from Q is equal to the C, delta V. So we got the Q total equal to C1 delta V1 plus C2 delta V2. And for the equivalent capacitance, we got that the equivalent capacitance across the combination equal to C1 plus C2 plus C3. Then we move to the next, which is the series combinations. And for the series combinations, the charge across the combination is equal to the charge of the first or second or the third of the capacitors, which is all of them are the same. So because of that, the potential difference across the combinations equal to delta V1 plus delta V2 and so on. Lastly, for the equivalent capacitance for the series, the equivalent capacitance can be defined as 1 over C equivalent equal to 1 over C1 plus 1 over C2 plus 1 over C3.
My name is Ahmad Syami Hazwan bin Ahmad Tajuddin, and my metric number is 210335. Okay, I will continue this presentation with energy stored in a charge capacitor. A capacitor usually can store energy. This is because positive and negative charge are separate in the system of two conductor in charge capacitor. Electric potential energy is stored in the system. So we can see from this diagram, the charge is separate in the system. This is the positive charge and this one is the negative charge. So there are three equations that we can use to calculate the energy stored in a charge capacitor. This is the first one, the second, and the third. Okay. These three equations can apply to any capacitor regardless of its geometry. For a given capacitance, the stored energy increases as the charge and the potential difference increase. Okay. Last but not least, we move to the dielectric. A dielectric is a non-conductor material such as rubber, glass, or wax paper. We can perform this experiment by insert the electrode between the plates of capacitor. The capacitor increased by a dimensionless factor K called the dielectric constant. And this is the equation. C is equal to Kc. This first C is the value of the capacitor after insert the dielectric. The K is the constant, the dielectric constant, and the C here is the initial value of capacitor. So there are a few advantage when we provide the electric. Firstly, it can increase the capacitance. The second, it can increase in maximum operating voltage. And lastly, it can decreasing in distance between plates.
Next, we move to the example question for this. Okay, for the first question is find the equivalent capacitance between points A and B for the group of capacitance concept as shown in the figure above. Take C1 is 8 microfarad, C2 is 13 microfarad, and C3 is 5 microfarad. In this question, the equation that we need to use is the series and parallel for capacitance. For the series capacitance, we use to find the C equivalent, we use this equation, which is 1 over C equivalent equal to 1 over C1 and 1 over plus 1 over C2. While for the parallel, to find the C equivalent, we just add C1 and plus C2. To solve this question, we consider all of this which A and this which B. Okay, C1 and C2 is we consider as a series, but C3 is parallel to the C1 and C2.
To calculate C1 and C2, C equivalent, we use series equation, and we got we use C equivalent 1 over 8 plus 1 over 3. So C equivalent here we get 4.65 microfarad. Since the left one and the right one is same, so we just add the same value as we calculate before, which is 5.65 microfarad plus 5.95 microfarad. After that, we use a parallel equation to calculate the A for A, which is we just add 5, which is capacitance 3, and for the A we get 14.9 microfarad. Next, we must calculate for B. For B, C2 and C2 are in the parallel, so we just add this the value of these two of both value, which is 13 microfarad plus 13 microfarad, and we get 26 microfarad. And last but not least, we calculate the total of the total of equivalence capacitance, which is A plus B. A and B are in the series, so we use series equation to calculate the total. So the equation is 1 over C equivalent equal to 1 over 14.9 plus 1 over 26, and we got the C equivalence total is 9.47 microfarads.
Now we move to the next example. Okay, the voltage. The question is, the voltage across an A-fed parallel plate capacitor is measured to be 182 volt when a dielectric is inserted and completely fills the space between the plates as in the figure below. The voltage drops to 86.7 volt. Okay, the question is, what is the dielectric constant of the inserted material? From this equation, we can define that the given information is the volt 182 and the another volt, it is 86.7. we can relate it to the equation delta V equal to V naught over K. Okay, K here is a dielectric constant, which the factor why the capacitance increase. Okay, we substitute the value into the equation. V naught equal to 182 and delta V equal to 86.7. Okay, we calculate the K and we got 2.09. Here we don't have a unit because K is a constant. Okay, that's all from us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.